My name's Adrienne Bartis, and welcome to my presentation on hexachlorobenzene. So hexachlorobenzene is an organochloride, and its molar mass is 248.8 grams per mole. Its boiling point is 612 degrees Fahrenheit, which is 322 degrees Celsius. Its density is 2.04 grams per centimeter, and its melting point is 231 degrees Celsius, which is 504 degrees Fahrenheit. Okay, so it's got like a fairly long history. It's a totally man-made substance, so it's not really found in nature. It was introduced in 1945 to as a way to treat seeds. It kills fungi that affect food crops, and it was widely used to control wheat burn. Because of this use, it contaminated all of the food, and it was used a lot in Turkey for all of their wheat. And so it ended up killing 4,000 people in the years 1955 to 1959. It was just in their food supply. They would go and buy stuff at the market, and then they would die from it. So it's considered an persistent environmental pollutant. It's like a white crystalline solid, and it's been used for mainly agriculture pretty much the entire time. It's in 2001, during the Stockholm Convention, it was one of the original 12 pollutants that were considered to be really bad. It was one of the dirty dozen, basically. It's not really produced so much anymore because of this, but it is still produced as a byproduct in the manufacturing of a lot of organic chemicals, such as fireworks, ammunition, and synthetic rubber. All right, so HCB affects a lot of different things. It affects the porphyrin synthesis and basically the proteins involved in the metabolism and transport of oxygen. Its main target organ is the liver. So long-term oral exposure to hexachlorobenzene in humans will result in liver disease and associated skin lesions, which is not pretty. HCB also acts as an endocrine disruptor in the thyroid, uterus, and mammary gland, and is classified as possibly cancerogenic to humans. There was a study that lasted about 15 years of research that assays the bioaccumulation of HCB in high-fat tissues during highly sensitive times of windows such as pregnancy, childhood, and adolescent, make the exposure a risk factor for for tumor development. There's very little information on what happens when you inhale it, so I don't have any solid information, but it's not good because it gets into your system that way as well. All right. So hexachlorobenzene is a POP, one of the persistent organic pollutants. I think I said that wrong. And so it persists in the environment for long periods of times. It strongly adheres to soil and poorly dissolves in water. So residues can remain in sediments of lakes and rivers. Its half-life in the soil can range between 3 to 6 years. The long-range atmospheric transportation of HCB to the Arctic and other areas very far away from where it's been produced. It's been found in the North Pacific Ocean, and it's been in the rainfall of 2 remote islands on Lake Superior. So because it persists and lasts and does not deteriorate very easily, it just spreads all over, and they found it in places that have been very far away from any source of pollution. Okay. So, methods for determination of these compounds generally consists of these 3 steps. All right. The primary gas chromatography, which is the process of separating compounds in a mixture by injecting gaseous liquid sample into a mobile phase. And they usually, once they have it into a gaseous mixture, they then do the electron capture detection. When the gases pass through the ECD, electron capture detection, some electrons of some molecules which pass through the detector are captured, and the current being measured reduces, which results in a positive peak being recorded. So that's how they find out if it's in this certain whatever testing thing you've got going. Or mass spectrometry, which is an analytical technique that is used to measure the mass to charge ratio of ions. The ratio is presented as a mass spectrum of a plot intensity as a function for the mass to charge ratio. Analytical methods have been developed for the determination of hexabenzene in blood, in like urine, and other tissues and excretions. Yes. Okay, so this is really bad. It's all over. It's bad for people. There's not really a good use for it. And it lasts for a very long time. It actually has a half-life of 3 to 6 years. That means half the total amount will disappear after 3 to 6 years. And then half the remaining amount will disappear in the following 3 to 6 years. So it takes about 12 years for it to disappear completely. And if it's released to surface waters, such as rivers and lakes and streams, the half-life is 2.7 to 5.7 years. Its half-life in air can range from 0.63 to 6.28 years. So remediation involves the removal of HCB from different components like soil, sediments, air, and water. Since HCB was highly detected in the soils and sediments, the majority of remediation technique adapted involves the destruction of HCB from soils. Since HCB was settled down in soils for many years due to its long half-life. So it just piles up over the years, and because it's not deteriorating immediately, it just increases. So there are several techniques to destroy these deposits and traces of HCB. One of them is base catalyzed decomposition, in which high-grade impacted soils and waste can be treated with this technology. BCD technology treats contaminated media by mixing it in with an alkali sodium bicarbonate solution and heating them in a thermal distortion reactor between 315 to 500 degrees Celsius, which evaporates the halogenated compounds. The high temperature dehalogenation. This technology is used to treat high-grade waste contaminated with pesticides and stockpiled material by using the byproducts of calcium salt, elemental carbon, and hydrogen, all of which are non-hazardous reaction products. The high-temperature incineration is basically just burning it at a high temperature for 450 degrees to 110 degrees 1,100 degrees Celsius in a continuous indirect feed under a vacuum pressure of about 50 pounds in the absence of air. The contaminants will then be vaporized and eliminated. The last method is the gas phase chemical reduction. So this technology is used to clean up impacted media with all forms of higher grade POPs at a full scale to very low residual levels in a sealed system. High grade POPs, like this one, impacted soil sediments and extracted waters can be treated by this process uses 2 stages to achieve removal of HCB. In the first stage, materials are heated to 600 degrees Celsius without oxygen in a batch process. This desorbs the POPs, HCB, in volatile. Oh, wait, I lost my place. Yes, that volatilized in the treated soil is allowed to cool. In the second phase, gas vapors from the initial reaction pass to the GPCR reactor, where they react with H2 gas at 850 to 900 degrees Celsius. And those are the different ways that they can get rid of it. Not that they are doing much on that now. There are high contaminant sites that are being used that are using these processes to clean them, but they can be found pretty much everywhere, but in smaller doses where it's not an immediate concern. So these are the main places where I've got my citations from. The Encyclopedia of Toxicology, very helpful. The bioaccumulation and biomagnification of organochlorites in a marine food lab, also very handy. There was a study about fish being, well, the bioaccumulation and biomagnification, which it does happen in fish and people and other animals that eat it often. And impact of endocrine disruptor and pretty much all the sources. They also have a lot of information on EPA websites. And yeah, so thank you for coming to my PowerPoint. I hope you've enjoyed it, and I hope my fumbling over words didn't make it that painful to be watching. Thank you so much for your time. Bye.